What's up, geometry scholars? In today's class, we're going to be analyzing regions questions involving dilations. Let's jump right on in. Question number 13. The coordinates of the endpoints of segment SC are -7, 3, and 2, -6. If we've got this point M on SC, what are the coordinates of M so that it's split in a 1:2 ratio? So our objective is to figure out the coordinates of M, and I recognize that on this segment, we're going to have three parts. We've got S on the left side, we've got C on the right side, and our objective is to figure out what the coordinate is for right here. This is what we're going to describe as M, and it's where it's split in a 1:2 ratio. Great. And here's what I know. I know that we've got some X values, right? We've got -7 and 2, and so I'm going to include that right here. -7 and 2, and then we've got these Y values. We've got 3 and -6. And so let's include that as well. Okay, and I see that just looking at it, I can see that the X values are increasing and the Y values are decreasing. And you know what we're going to do? We're going to need to figure out how much the X values and the Y values are changing each time per part. And so let's do that right now. So we need to figure out the distance of the X values. So what I'm going to do is simply 2 minus -7, and that's going to be +9. All right, and so what's the distance divided by the number of parts? So we're going to have 9 divided by 3, and that's going to give us +3. It's going to be increasing by 3 each time. That makes sense. Let's take a look at the blue Y values, and the distance of the blue Y values is going to be -6 minus 3, and that's going to give us -9, and that makes sense, right? If we're going from 3 to -6. And so let's do the distance divided by the number of parts, and that's also going to be 3. And -9 divided by +3 is going to be -3. Okay. All right. So let's apply these delta x and delta y to these values. Okay. We're going to be starting with -7, and so -7 plus 3 is going to be what? It's going to be +4. And then you know what? Let's keep it moving. Um, I'm so sorry. It's going to be, of course, -4. What's -4 plus 3? It's going to be -1. And then what's -1 plus 3? That's going to give us 2, right? And that's exactly where we want to be. Amazing. Let's see if this works out for the y values as well. So we're going to start with 3. And so 3 minus 3 is going to be what? It's going to be 0, of course. What's 0 minus 3? 0 minus 3 is going to be -3. And then -3 minus 3 is going to be -6. And you know what, ladies and gentlemen, this checks out. And did we figure out our answer? We sure did. The correct answer is -4, 0. Let's take a look at question 22. It says point P divides the directed line segment from A to B in the ratio 2:3. Our objective is to figure out what the coordinates are of point P. So let's sketch this out. So here's what I know. I know that we've got this segment, and it's split in a 2:3 ratio. Beautiful. And that's going to give us 5 total parts. We've got A on the left side, and we've got B on the right side. And if it's going to be split in a 2:3 ratio, we're looking for the coordinate right here. Beautiful. You know what we'll do? We'll call that point P. That's our objective. All right. If we've got these X values, and I can see that the X values are 6 and -4, and we've got these Y values, -1 and +4, let's label this diagram. All right. So A is going to be -4, B is going to be +6, and we've got A is going to be -1, and B is going to be 4. Beautiful. All right, so let's jump right on in. The first thing that we're going to need to do is figure out the distance of the X values and of the Y values. All right, so let's take a look. I know that 6 minus -4 is going to be +10. And so what's the distance? I know that it's going to be 10 divided by the number of parts, which of course is 5. And so what's the change per part? It's going to be +2. It's increasing by 2 each time. The Y values is going to be 4 minus -1. And so that's going to give us positive 5. The distance is going to be 5 over 5. And so the change per part is positive 1. Beautiful. All right, so let's apply that to this segment so we can figure out what the coordinate is for point P. And I know that negative 4 plus 2 is going to be negative 2. Negative 2 plus 2 is going to be 0. And if we just keep it moving, 0 plus 2 is 2. 2 plus 2 is 4. 4 plus 2 is 6. And you know what? Ladies and gentlemen, that totally checks out. Let's apply the y values. We're going to start at negative 1. So negative 1 plus 1 is going to be what? It's going to be 0. 0 plus 1 is going to be just 1. And then we've got 2, 3, and 4. That was pretty straightforward, right, guys? And did we figure out the relevant coordinate? We sure did. The correct answer is 0, comma, negative 1. Next question. In the diagram below of triangle ABC, we've got TV intersecting AB and AC at points T and V respectively. And then it says that angle ATV and ABC are congruent to one another. And that's critical because if we zoom in and we mark up the diagram to reflect that, what do we know? I know that this length and this side length are parallel to one another because of corresponding angles. You know what, guys? I also recognize that we've got two triangles here, right? We've got this smaller triangle and we've got this bigger triangle. And the smaller triangle is a dilation of ABC, or that's similar to one another. Because why? Because we've got a shared angle between them. Beautiful. All right, so let's go ahead and label this diagram and think about the objective. And it says if AT is 4, and I'm going to label that right here. So if AT is 4 and BC down here is 18, TB is 5. All right. And then it says AV is 6. It now says our objective. We got to figure out what is the perimeter of this quadrilateral. So we're looking to add up the side lengths of this quadrilateral right here. And we know the 5, we know the 18. We have to figure out TV, we're going to have to figure out VC. And what we can do is we can recognize that this triangle is similar to ABC. And we know that the ratio of AT to AB, the entire length, is 4 to what? It's 4 to 9, because 4 plus 5 is 9, of course, and AB is 9. And so the scale factor can be used to figure out the missing lengths, including TV and VC. So let's go ahead and do that right now. All right, so I know that AT is going to be 4, and I know that AB is going to be 9, and that's equal to what if we're going to be setting up a proportion? And we want to think about what side are we going to be solving for. Let's solve for TV right now. Let's solve for TV. So I know that TV is going to be on the top. And then on the bottom, we're going to have 18. And that makes sense. All right. So we're going to have 9 times TV is 9 TV equals 4 times 18. I know is 72. We're going to divide both sides by 9, meaning that TV is going to be a total of 8. 72 divided by 9 is 8. Great. So we've got one length to go. And you know what I know? Since TV is parallel to BC and it intersects along the left side and the right side, then it's dividing AB and AC proportionally. And so we can do is we can simply figure that out. So I know that if we set up a proportion like AT over TB equals AV over, and let's call it VC, what we can do is then we can simply plug in the values and we can solve for this proportion. Beautiful. And let's do that together right now. So I know that we're going to have 4 over 5 equals 6 over VC, right? We definitely need to figure out what this is. And so what we can do is we can multiply 4 times VC, and that's going to, of course, I'm going to write it right here. That's going to give us 4 VC, and that equals 5 times 6 is 30. We're going to divide both sides by 4, and VC is equal to what? 7.5. Great, I'm going to jot that in right now. Beautiful. And so again, our objective is to figure out what the perimeter is. So what we're going to do is we're going to just add these up. We're going to add 8 plus 7.5, which we just figured out, right? Plus 18 plus 5. Those are the 4 sides. And what exactly does that give us? That gives us 38.5 units. That is option 1. We did it.